Picture the leftover rice you made for lunch. You left it on the counter for a few hours, then scooped it into a pan, cranked the heat, and stirred until it was steaming and sizzling hot. You probably figure that kind of intense heat is the great equalizer. We're taught that high temperatures act as a sledgehammer, wiping out standard bacteria or the germs on a sketchy piece of raw chicken. But even after you blast that rice hot enough to burn your tongue, eating it can still send you straight to the bathroom with severe, rapid-onset food poisoning. Your instincts aren't wrong, but in this specific case, they fail completely. You're approaching the problem like a standard biological threat, which means you're fighting the wrong enemy. Whatever survived boiling water once, room temperature for hours, and a second round of screaming hot heat isn't a germ. Your stove is absolutely useless here, because you are treating a slow-motion, invisible chemistry experiment like an ordinary kitchen pathogen. The culprit starts with a bacterium called Bacillus cereus. It naturally lives in soil, which means it rides into your kitchen directly on raw grains of rice. In its active state, it's incredibly weak. Boiling water normally destroys it instantly. But Bacillus cereus has a specific biological trick. When the temperature starts to climb and conditions get lethal, the organism dehydrates itself. It shuts down and coils its DNA into a heavily armored capsule called a spore. A spore is built to shrug off extreme thermal punishment. To kill these capsules, you would have to hold them just below boiling for almost 45 minutes. A standard rice cooker clicks off long before you hit that threshold, leaving those invisible survival pods completely untouched in your freshly cooked meal. And the boiling water actually helped those spores. The heat cracked open the hard starch granules in the rice, flooding them with moisture in a process called gelatinization. It turned a tough, dry grain into an easily digestible, moist food source. So your initial cooking process didn't sterilize the rice. All it did was set up a warm, all-you-can-eat buffet for the indestructible spores that hitched a ride inside the bag. This scale shows the critical window food scientists call the danger zone. It spans from roughly 41 degrees to 135 degrees Fahrenheit, or 5 to 57 degrees Celsius. Below this, in the fridge, life slows to a halt. Above it, on the stove, heat destroys most threats. But right in the middle, your kitchen counter acts as a highly effective warm incubator. The moment the temperature drops into that comfortable middle ground, those resting spores sense the warm, moist environment. They break out of their armor, rehydrate, and immediately begin rapidly multiplying across the starchy surface of your rice. The multiplying bacteria do not directly make you sick. Instead, as they feed on the swollen starch, they manufacture and secrete a byproduct directly into the rice, a specific chemical weapon called Cereulide. This is the distinction that decides whether you spend the night by the toilet. The bacteria are living organisms. You can kill them. Cereulide is not alive. It is a chemical molecule, and you cannot kill a molecule any more than you can kill a rock. Because it's just a tightly coiled ring of chemical building blocks, breaking Cereulide apart is absurdly difficult. This molecule easily survives continuous exposure to 250 degrees Fahrenheit or 121 degrees Celsius for up to 90 minutes. To put that kind of heat into perspective, that is the exact operating temperature of a pressurized medical autoclave. A hospital uses these steel chambers to annihilate every trace of life on surgical instruments. Cereulide sits through that exact same environment completely unbothered. Since it ignores intense heat, it easily survives the journey into your body. It sails perfectly intact through your stomach acid, reaches your gut, and latches onto a specific receptor that directly triggers your brain's vomiting reflex. When you toss that leftover rice into a hot pan for dinner, you successfully wipe out the bacterial factories. But the heat does absolutely nothing to the loaded stockpile of chemical weapons they already left behind in your food. Since the chemical toxin cannot be cooked away once it exists, the only solution is to intercept the manufacturing process. The point of failure was never how you reheated the food. The mistake happened hours earlier, during the slow, unhurried cooling phase, while the bowl just sat out on the counter. This chart shows the exact safety curve you need to follow. The thermal clock dictates that you must force hot food down through the danger zone to room temperature within 2 hours and get it into the fridge shortly after. To achieve that steep drop in temperature, You have to stop storing hot rice in giant, dense mounds. A deep bowl of starchy food insulates itself, trapping that core heat and keeping the center squarely in the danger zone for hours. Instead, you want to manipulate the thermal variables. Spread your leftovers thin across a wide, shallow container or a baking tray. This maximizes the surface area, allowing the heat to vent rapidly into the air before refrigeration. And this protocol applies identically to any gelatinized starchy food. A steaming pot of pasta or a pile of boiled potatoes obeys the exact same rules, harbors the exact same spores, and manufactures the exact same toxin. True kitchen safety comes down to understanding how time and temperature govern chemistry. Control those two variables, and you easily outrun the danger long before you ever turn the stove back on.